Okay, so I started recording this and didn't have the volume on. So I already started writing, so I'm just gonna walk through this. Um, so what I've done right here is in blue, but I'm gonna walk through it starting right here. So we know with our sequence, um, we the index is 1, so it starts at 1 and goes to infinity. Since our n is gonna be greater than or equal to 1, we know the first term is 1/4. We might not care to know that, we might, but if we plug in 1 here, that would be 1/4, okay? And if you wanted to, you could find out like your next term in the sequence. That would be 1/8, because 4 times 2. Then 4 times 3 is 12. 4 times 4. And we can get on and we can kind of look at this and we see it's decreasing. But let's also talk about why. So if I know that 4n is less than 4 to the n plus 4 times n plus 1, because this would be n and then the next term would be n plus 1. So if this is true, then when you flip it, you have the reciprocal, then instead of 4, you had 4n less than, this is going to be 1/4n greater than. So that means this right here was our first term, a sub n. This represents our second term. So this is showing that the first term is greater than the second term, which would then also mean that the second term is greater than the third term, and so on. So this sequence is decreasing. Because it is decreasing, it is monotonic. Remember that if something is decreasing or increasing, it's monotonic. If it's not increasing or decreasing, then it's not. Okay? So now we know it's bounded above at 1/4. We actually showed that up here when we were looking. But also you can you could do it later if you hadn't already done it. So then we have to see like bounded below. So we notice it's going to keep going down, getting smaller, smaller, smaller. But our denominator is never, going to be negative. So our bound below is at 0. Also, you could look at that when you take the limit of this 1/4n, that goes to 0. Alright, so now looking at number 2. So I will scroll down as we get to it. So we're looking here. I just rewrote the sequence over here. And so when I want to talk about whether or not it's increasing or decreasing, you have to take this -1 into account, because that -1 is telling us that what's happening with this sequence. -1 to an exponent that's going to keep changing, that -1 to -1 and +1, means that this is going to alternate. So if I look here, when I substitute in that n equals 0, my first term is going to be 0 times +1, which is 0. But my next term, I would have 1 times -1 to the third power, which is 1 times -1. I'd have -1. Then, when I substitute in a 2, I would have 2 times a +1, which is 2. Then, when I substitute in a 3, I would have 3 times -1 to the fifth, so that's a -1. 3 times -1 is -3. And we can keep substituting in. It's going to keep doing this. It's going to keep alternating. And so that's something we look at. That's something we note. And it's very important because since it's alternating, it's not increasing or decreasing, which also means it is not monotonic. It's not increasing nor decreasing. Not increasing nor decreasing. Okay, so now we want to talk about whether or not it's bounded. So at first I kind of look at this and I'm like, oh, 0. No, 0 is not a bound because it goes below 0. It's going to keep going below 0 to infinity. Then I think, okay, was it bounded above? So just right there I can tell you it's not bounded below. Not bounded below because it's going to negative infinity. And someone had said that it was bounded at negative infinity, but it can't. So to be bounded, it cannot go to positive infinity or negative infinity. To be bounded, it has to fit between two finite numbers. They do not have to be whole numbers, but they have to be finite numbers. Not bounded below. And if you look, it's not bounded above. It's going to continue to increase. So it's not bounded below and not bounded above. Therefore not bounded. Okay. So now we want to look at number 3. Number 3, we can kind of follow the format of number 1, and let's talk about why. So in number 3, we have the sequence 3 to the negative n equals 0 to infinity. Now, what do we know about negative exponents? A negative exponent is the same as having 1 over 3n. So now if I look at this, this is very similar to what we had in number 1. Difference is that my index here starts at 0 and it goes to infinity. So I can look at this the same way. If I think about 3n and 3 to the n plus 1, then I know 3n, in this case, 3n is going to be less than n plus 1, less than or equal to, no, it's going to be less than, ignore me, it's less than, because if you substitute in a 0, 3 to the 0 is 1, 3 to the 1 is 3, so if this is the case, then we know 1 to the 3n is greater than 1 to the 3n plus 1, which tells me a sub n is greater than a sub n plus 1, which implies the sequence is decreasing. The sequence is decreasing. And because it's decreasing, it is also monotonic. Okay? So now we have what we said before is our very first term is 3 to the 0 power, which is 1. So if we're thinking about this, and I want to think about my sequence, I know that my first, I'm going to have 0, not 0, we just said 3 Oh my goodness. Alright. 1 over 3 to the 0 power is 1 over 1, which is 1. Well, then 1 over 3 to the 2nd power would be 1 over, hold on, my keypad keeps coming unconnected. Alright, 1, that would be 1/9. And then 3 cubed would be 127. And you're going to notice the numerator is going to keep getting larger. And so the fraction's going to keep getting closer to 0. So we can say that the sequence is decreasing in monotonic. The sequence upper bound is 1 and lower bound is 0. Therefore, bounded. If it's bounded above and below, then it is bounded. Okay, so we're halfway. We're going to look at number 4. Okay, so number 4, for this one, what we're going to do to determine if it's increasing or decreasing is we can differentiate, and if our derivative is always positive, then it's an increasing function. So, looking, I'm going to put this in terms of f of x. So for number 4, if I have f of x equals 2x squared minus 1 over x, when we differentiate, we would implies that the derivative, and if you remember, when you take the derivative, you do your denominator is going to become the denominator squared, and then you are going to take the denominator and multiply it by the derivative of the numerator. Hold on. I can't pause this, but just give me just a minute. I'm at the house. Okay, sorry. Okay, so you do the denominator times the derivative of the numerator. So the derivative of the numerator is 4x, and then subtracted by the numerator times the derivative of the denominator, and that's 1, the derivative of this part, the x. So I don't know if you learned this like little thing to help you remember the quotient rule, but low d high, meaning the low, the denominator, times the derivative of the numerator, subtracted by high d low, which would be the numerator times the derivative of the denominator divided by the denominator squared. So doing that, you would have, I don't know why I put a squared there. It would be x times 4x, because I'm using this x. So that would become 4x squared minus 2x squared minus a negative 1 becomes a plus 1 all over x squared. That becomes 2x squared plus 1 over x squared. So because both our exponents are squared, we know that we're always going to have positive, because even if x was negative for some reason, we're going to have positives. There's plus signs. We are good. If the derivative is always positive, that, well, when x doesn't equal 0, which in this case it doesn't, because it starts starts at 2. So when x does not equal 0, that implies that it is increasing, which implies that it is monotonic. Okay, and so we want to know, is it bounded? Okay, so we look, and we can look for the to determine, you know, if since it's increasing, then we can see, like, is there a lower bound? What is the first term? So the n is 2, so our first term would be 2 times 2 squared minus 1 divided by 2. That would become 8 minus 1 over 2, which is 7/2. So it's increasing, so that 7/2 is the lower bound, because that's the first term. Now it's increasing, so we ask ourselves, what is the limit as n goes to infinity for 2n squared minus 1 over n? And so, you know, if I just simplify dividing by that n, that becomes 2n minus 1 over n. And when I take the limit, that's going to be infinity minus 0, which is infinity. And just be reminded that if it approaches infinity, that means there is no upper bound. Not bounded because there's no upper bound. There is a lower bound, but there is no upper bound, therefore it's not bounded. Okay. Now number 5. So I think I can fit number 5 here. I'll do it in a different color to just really help differentiate. And I'm sorry that my voice is starting to go, but we'll get through this. Only 2 more problems. So number 5, we have the 4 minus n divided by 2n plus 3. So again, if we want to differentiate, we know f of x is 4 minus x, 2x plus 3. When we differentiate, we do, I'm going to even write it up here, low D high minus high d low divided by a low squared. So if I'm doing that, 2x plus 3 is squared. And then the low, which was 2x plus 3, times the derivative of the high. So the derivative of the numerator here is a negative 1. So that becomes negative 2x minus 3. Then minus, we have high, which is 4 minus x, times the derivative of the low. The derivative here is 2. So that would become minus 8 minus 2x. So simplifying, negative 2x minus negative 2x cancels. Negative 3 minus 8 is negative 11 over 2x plus 3 squared. I don't think it's really any reason to take the denominator out and square it with FOIL or anything, because we can look at this and get what we need. You see this negative? The bottom is always going to be positive due to that squared. So since the derivative is always negative, then this is decreasing. The sequence is decreasing. Now, if you remember in the previous one, the derivative was positive, so it was increasing. The sequence is decreasing, and that makes it monotonic. So now we want to determine whether or not it's bounded. So it's decreasing. So whatever the first term is, it's decreasing. So the upper bound is going to be that first term. So we say our index is 1, so we would say 4 minus 1, 2 times 1 plus 3. That gives me 3/5. This is the first term, your a sub 1. So a sub 1 is, I was going to put is your, but it is the 3/5 is the upper bound. And then from there it decreases. So to find to see if there's a lower bound, we can take the limit as n approaches infinity of 4 minus n over 2n plus 3. So in the last problem, it went to infinity, so it wasn't bounded. However, in this problem, when we take the limit, okay, we would end up with 4 over n minus 1, 2 plus 3 over n. And as I take the limit, that's 0 minus 1, so negative 1. 2 plus 0 is 2, so negative 1/2 is my lower bound. Fun, fun. So this sequence is bounded because it has an upper and lower bound. Is bounded because it has an upper and lower bound. Okay. Lastly, we have negative n over n squared plus 25. So we can take the derivative. So, remember when we take the derivative, if our derivative is always positive, it's increasing. If it's always negative, it's decreasing. If it's not, then it's not either. So we have negative. We do this in terms of x when we take the derivative. So the derivative here, again, you can do high d low minus low d high. And if we do that, your denominator is going to be x plus 25 squared. So low is x squared plus 25 times the derivative. The derivative of negative x is negative 1. So that's going to become negative x squared minus 25 minus high d low, which would be the negative x times 2x. So negative x times 2x is negative 2x squared. Okay, yep. And so simplifying that, negative x minus negative 2x squared becomes x squared minus 25 over x squared plus 25 squared. So, looking here, the denominator is always going to be positive because it's squared, but the numerator is not going to always be positive. So, if it's not going to always be positive and it's not going to always be negative, then it's not increasing and not, or decreasing. So, there's some positive and some negative in that derivative. Therefore, neither increasing nor decreasing and not monotonic. Oh my goodness, not monotonic. Let me make this look better. Okay, now bounded. So we said that it's decreasing on some, like at some places. So where is it decreasing? So where would it be negative? So this would be decreasing. It would be negative when n is it's going to be negative when n, or when the x is less than 5 but greater than or equal to the 2. It has to be greater than or equal to 2. It is increasing from n greater than 5, which means n equals 5 is the minimum. It would be 0. Minimum. Okay, spelling. So if n equals 5 is the minimum, we can find out the lower bound by substituting in 5. So if that's the minimum, sub 5 into the sequence to determine the lower bound. To determine lower bound. Okay, so I'm going to say negative 5 to 5 squared plus 25, which is Negative 5 over 50, which is negative 1/10, is lower bound. And for the upper bound, we would try to take the limit. Upper bound, we would say the limit as n approaches infinity of negative n over n squared plus 25 is the limit as n approaches infinity. 1 over n squared, because you divide by the n squared. So we know that the numerator approaches 0, the denominator approaches 1. So the limit is 0, so that's our upper bound. The upper bound is 0. And it's bounded. You could even say it's bounded from negative 1/10 to 0. And so back at number 5, you could say it's bounded from negative 1/2 to 3/5 if you wanted to. So I will get this uploaded and I will have you guys your first test. Let me know if you have any questions.